And here it goes. Hey guys, welcome. New unit, Unit 3, Systems of Equations. Nothing new. Algebra 1. Even probably geometry. Reminder, this is where you have two equations. You put them together, you either substituted, you eliminated, you graphed, you did one of those things to figure out what x and y is. Well, today we're going to go over graphing, substituting, elimination, and then the special types, the parallel, and what it means when it's a line on top of a line. Many solutions. Pretty simple. I'm going to be giving you about 4 or 5 examples, 2 of each one, so see how it goes. So what is a system of equation anyways? Reminder, a linear system includes 2 or more equations. For this section, we're only doing 2. Oh yeah. But in about 4 sections, we're going to have maybe 3, maybe 4. Getting a little tricky, a little fun, a little exciting, or I think it's fun and exciting. When 2 equations are used to model a problem, we call it a linear system. Some things you need to know, some terms you need to know. Linear system, 2 equations that form 1 equation. Solutions. So when you have an answer, you need to put them in an ordered pair, an x, a y. You don't say x equals blah, y equals blah. You need to put ordered pair. And isolate. If I say isolate, that means get the term alone. Either x or y, depending on what I'm saying. Here's a joke. I thought it was funny. Read it to yourself. I would read it, but then I'm going to laugh like a hyena, so I'm not going to. Alright, first 2 examples are by substituting. Reminder, basic steps. Solve for one equation. Substitute the expression into the other equation and solve for the other variable. Substitute that value into the first equation and then solve. Check your solution. So here's an example. 2 equations, right? Which one do you solve for? It doesn't matter. You can solve for top or you can solve for bottom. You're going to get the same equation. Let's say I go, this one looks pretty easy to solve for. Why does it look pretty easy? Well, y is already have a 1 in front of it, and that would be one step. How do I get y alone? I'm going to add x to both sides. Negative x plus x cancels out. So I have y equals x plus 1. So you're substituting it in. How many of you bake? It's like putting butter instead of margarine, or margarine instead of butter. It's the same thing when you're making cookies. You can replace them in there. Same thing. I'm going to replace y equals x plus 1 because that is the same as this top equation. So I'm going to put it in the second equation right here. Instead of this y, I'm going to replace it with x plus 1. So I have 2x plus x plus 1, because that's what this y was, equals negative 2. Can you solve for that? You betcha. Add your like terms. 2x plus 1x is 3x plus 1 equals negative 2. Solving for x, nothing new here. X equals negative 3. So what does x equal? Negative 1, because I had to divide both sides by 3. We just did step 1. We solved for it. We did step 2, where we solved for one letter. Now we're going to substitute. Oh, just kidding. We also did step 2. I'm sorry. We substituted this in for y. Step 3 is we solved for it, and now I'm going to use this x and put it into either equation. It doesn't matter. Which one do you think looks simple? I think the first one does. So I'm going to put negative 1 in for this top equation. So a negative, because that was a negative x, negative 1 plus y equals 1. Well, what's 2 negatives make? Yeah, 1. So what's 1 plus y? Equal 1. How do I solve for y? So I have y equals 0. So here's my answers. Did I tell you to leave it in this form? No, I told you to leave it in an ordered pair. I don't know why I wrote a 3. So my answer is negative 1, 0. Bam. If you wanted to, you could go into check. I am not making you guys go back to check, but you could. You could say, okay, negative 1, negative 1 plus 0, what does that equal? You bet, because 2 negatives make a positive, so what's 1 plus 0? 1. Yep, that works. What about the bottom one? Would have worked for that one. What's 2 times a negative 1? Plus 0. Does that equal negative 2? Well, let's see. What's 2 times a negative 1? Yeah, that's a negative 2. What's 2 plus 0? Yeah, that's a negative 2. Yeah, that works. So does my answer work? You bet. Do you have to do that for all of them? No. Just showing you that it works. If it's on a test, I recommend it. Few tricks of the trade. It doesn't matter if you choose to solve for y or x first. The answer or solution will be the same either way. You should always decide whether to solve for x or y. Sorry. The equation that looks simpler. That's what I say. Make it efficient. So, for example, if I had deciding on which one to solve for, the 3x minus 2y equals 1 or the x plus 4y equals 3. Which one are you going to solve for? If it was me, I would solve for this bottom one. Why? X has a coefficient of 1, and it's going to take me one step to solve for x, to isolate x, to get it alone, by subtracting 4y from both sides. So I have x equals 3 minus 4y. Step 1's done. Step 2 says plug this in to your other equation you didn't use. Well, I didn't use this top equation, so I'm going to plug it into this 3x right there. The 3 stays in front, so I have 3 times 3 minus 4y minus 2y equals 1. Distribute, you can do that. Oh yeah. 9 minus 12y minus 2y equals 1. 9 minus 12y is negative 3y minus 2y equals 1. So what's 3y minus 2y? Yep, that is negative 5y equals 1. Divided by negative 5. So what does y equal? Ooh, we got a fraction. That's okay. We are in not geometry, algebra 2. Alright, have that. I'm going to use it. What step am I on? Step 4. Plug it in. Doesn't matter which one you plug it into. Let's say I plug it into this equation right here. So I have x plus 4 instead of y, plug in a negative 1/5 equals 3. So what is 4 times a negative 1/5? You don't know that? Get a calculator. Otherwise, it's multiply your numerators, multiply your denominators. So x plus a negative 4/5 equals 3. Now, how do you get rid of that negative 4/5? Add 4/5 to both sides. So x equals 3 and 4/5. Reminder, this is not how you put your answer. How do you put it in? So 3 and 3/4, or 3 and 4/5, I'm sorry. Oh, come on, erase for me. 3 and 4/5 and negative 1/5. That is your x and y. You can plug that in for either equation and it would work. Alright, that's substitution. Remember that? Just another little joke for you. Switching it up a little bit. Elimination. Reminder, there's elimination by adding, subtracting. There's elimination by multiplication. Basic steps. Arrange the equations so you have your like terms in the same column. After looking at the coefficients of x and y, you need to multiply one or both equations by a number that will give you the new coefficient. So x and y are opposites. For example, negative 12x and positive 12x. One's a negative, one's a positive. They have the same coefficient, which was 12. Add the equations and solve for the unknown variable. Then you're going to do what you just did, substituting it back in and check your solution. Here's your first example. Look, does 3 or 4 have the same number in front? Or not 3 or 4. Does x's have the same number in front? No. Does y have the same number in front? No. So I couldn't add them right now and eliminate. So what you have to do is multiply. Hopefully this is coming back to you for a little bit. What is your lowest number that both 3 and 4 go into? 12. Okay, what's your lowest number that 5 and 2 go into? 10. Doesn't matter what you use. I'm going to get rid of the y's. I want to make these a positive 10y and a negative 10y. So I'm going to multiply the top equation by 2, because that will give me a positive 10. Multiply the bottom one by a negative 5, because that will give me a negative 10y. Goal, eliminate the y's in this problem. So I got 6x, if I distribute, plus 10y equals 12. That was my top equation. On the bottom, negative 20x plus a negative 10y equals a negative 25. Now, do either x's or y's have the same number in front? You bet, your y's do, right? So if you add your equations together, these will eliminate. So what's 6x plus a negative 20x? That's a negative 14x. What's 10y plus a negative 10y? Those cross out. What's 12 plus a negative 25? It's a negative 13x. Boy, this is not going to come out pretty, is it? We're going to get a decimal. Did I do my math right? 2 times 3 is 6. 2 times 5 is 10. 2 times 6 is 12. Yep. 5 times 4 is 20. 10. 25. It's going to be right. Divide by both sides. That's okay. Ooh, there shouldn't have been an x here. We're not afraid of no fractions. I ain't afraid of no ghosts. Ooh. Okay, 2 negatives make a positive. So 13 over 14. That's x. How do you solve for y? Plug it in. Which one do you want to plug it into? I'm going to use this bottom equation. Y, just because 4 is even, it'll be easier. So I go 4 times 13 over 14 plus 2y equals 5. I have no idea what 14 over 13 over 14 times 4 is. So I'm going to do some math up here. Dun, 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 dun. So my answer would be 2 times 23 is 26 over 27, or 26 over 7. How many times is 7 going to 26? We got, what, 3 times with 5/7 left over? Yup. So 3 and 5/7 plus 2y equals 5. Minus 3 and 5/7 to both sides. Oh. I'm making sure that it is my pins going up and at me. Just kidding. 3 and 5/7. So 5 minus 3 and 5/7. You don't know it, get a calculator. Maybe you can do some simple math, hopefully. That would be 1 and 2/7. How do you get rid of this 2? Divide it. Divide it. Or you can say it's like the same as multiplying by 1/2, which I'm going to do because I don't have a calculator. I don't like calculators. 1 and 2/7 is the same as 9/7, correct? Times 1/2, because that's the same as dividing by 1/2, which would be 9 over 14. So y equals 9 over 14. Final answer, 13 over 14 and 9/14. Ooh, ugly problem, but did we solve for x and y? Yeah, so did we get the job done? Yeah. Reminder, they didn't have the same number in front, so I had to multiply to either eliminate x or eliminate y. And it's always easier if you make one a positive and one a negative. Pause whenever you need to. Play, rewind, take your notes. Here we have another problem I thought we'd do. Oh, in this problem, what do you notice? Yeah, your y's are the same, right? But they're both positive. So what if I multiply this bottom or this top equation by a negative 1? What's going to happen? I'm going to get negative 5x minus 3y equals 19. Now is one a positive and one a negative? Yeah. So you can add them together. Reminder, you add them together, that's going to eliminate your y's. Awesome. So I have 8x minus 5x is 3x. Negative 25 equals 19 is a negative 6. Divide by 3. X equals negative 2. Are you done? No. Reminder, plug it in. Substitute it. Which one do you want to use? Doesn't matter. We'll use this top equation right here. So I have 5 times a negative 2 plus 3y equals a negative 19. Negative 10 plus 3y equals a negative 19. Add 10 to both sides. So I have 3y equals a negative 9. Finally, an answer. We're getting some whole numbers too. Is that how you leave your answer? Heck no, we won't go. Put them in this form. Negative 2 equals negative 3. That is my answer. Bada bing, bada boom. Done. Pause. Copy. Move on when you're ready. Elimination by graphing is the last thing. Oh, I thought this was funny because it's kind of our school because we're all computer. But sometimes we don't use it correctly in your classrooms. or maybe at home. Okay, here we go. Basic steps. Put them into y equals mx plus b. Reminder, m is slope, b is y-intercept. Find the points, the lines that appear to intersect. So if I have this equation, these two, are they in y equals mx plus b form? No. Focus on this top one, bringing it down. How can I put this in the form of y equals mx plus b? Okay, minus x from both sides. So I have y equals a negative x plus a negative 2. Ooh, I don't like writing it that way. Let me try this again. Minus 2. So what are your slope in this problem? Well, my slope is a negative 1, and my y-intercept is a negative 2. So at a negative 2, and then it's down 1 over 1. Down 1 over 1. If I were to draw a line, it will look something similar to this. Next problem. 2x minus 3y equals negative 9. I'm looking to see where they intersect at. Subtracting 2x from both sides. Negative 3y equals negative 2x minus 9. Reminder, I didn't say negative 11 because they're not like terms. Divide by a negative 3. So I have y equals 2/3 x plus 3. So my intercept is at 3. My slope is up 2 over 3. Get me your line. So where do these bad boys intersect at? Right about here, right? So if you had to list that, you would eyeball it and you would say, well, that's a little bit more than a negative 3, so I'm going to say 3.2. And I'm almost at 1, so I'm going to say a 0.9. You can probably guess why graphing, elimination by graphing is not always the best, because you can't give me an accurate number, an accurate integer of where they intersect. But for this purpose, I want you to do it because pretty soon we're going to do inequalities. And you need to understand the graphing of equations before inequalities. Alright, let's try one more example. Oh, no we don't. Define the following. Trigonometry. What is trigonometry? A weapon of math destruction. Alright, don't let these fool you. No solution. No solution. If you were to graph these, they would be parallel lines. They don't intersect. Lines that don't intersect don't have a solution. Or you could say if I was to solve for these, they have no numbers in common. What if I multiply this top equation by a negative 2? So I would have a negative 4x minus 2y equals a negative 6. And then I had my bottom equation. What happens when you add these equations together? Yeah, look at your x's, 0. Look at your y's, 0. What did this come? Negative 2. Well, what's 0 plus 0? Is that a true solution? No. So that is no solution. If you were to graph these, you would get parallel lines. Do they intersect? Nope. So that's no solution. Alright, last one is if you had many solution, if you graphed them, it would be a line on top of a line. That means infinite, because everywhere they're touching is the solution. Or if you were to solve by systems by using elimination, say I multiplied this by a negative 2, because I want to get these y's out. So I have a negative 6x plus a negative 2y equals a negative 8, and 6x plus 2y equals 8. What happens if I add these together? X's cross out, y's cross out. Ooh, look at that. Your coefficients on the other side also cross out. So, does 0 equals 0? Is that a true case? You bet. So your answer would be infinite many. That is the symbol for infinitely many. Or if you were to graph this, the top equation would look like something like this. The bottom equation would be just a line on top of a line. So it would be like a really thick line. Everywhere they're touching is a solution. Alright, here, problem. Start these at home or come to class if you have your videos watched. Now you can download this before you even leave home. Hopefully you did that because you didn't get this message until just now. Questions, let me know. It's only 20 problems. Alright, good job guys.